Hey everyone, welcome back for another Build Hour. This is actually our first one of 2025, and we're really excited to be with you here today. My name is Sarah Urbonis, and I lead startup marketing here at OpenAI, and I am joined by Alon.
Yeah, I'm Ilan. I'm on the developer experience team.
So we always like to start Build Hour with kind of the goal of why we're here. And it's really to empower you with the best practices, tools, and AI expertise to scale your company using our APIs and models. Now, this series is really for all of you. So we take your feedback into what you want to hear more of, what you're building with, and hopefully this is a really valuable hour of your week that after this, you can accelerate what you're building and what you're creating with OpenAI. We have a new page here, webinar.openai.com/build-hours I wanted to plug. We heard your feedback that you wanted kind of a centralized place for all upcoming build hours. So now you can actually see all of the topics that we have upcoming. So we've been busy in 2025. As the kids say, we've been cooking. We had a lot that we've shipped this year and just kind of wanted to show a quick high level of what we shipped, what it does, and maybe what it means for you. We've had the Responses API, 4.1, 03, 04 Mini, Codex CLI, Codex. You can take a screenshot of this. We unfortunately don't have time to go through all of it in this hour. We might be here for a while, but we're going to try to show you as many new features and models as possible today. So obviously there's one big one that is missing from this list that we launched, which is image gen. And we know that that got a lot of attention from you all. Next week, we're actually doing a build hour on image gen where we'll talk about how you can leverage the API for whatever you're building. And yes, we might make a Studio Ghibli image or two during that build hour. But today's is really going to focus on the flagship models, increased context, and also Codex and how you can start building with it today. So for our agenda, we're first going to start out with some core concepts. We will talk about what's new, maybe set up a task with Codex, and then go into some core concepts and talk about reasoning, agentic tool calling, and tasks. As always with Build Hour, we really want this to be hands-on and get you into our code base. So we're actually going to anchor most of today's session on demos. And I think that we shared the code repo in the chat. So you can follow along with what Alon is building and build it yourselves after this, hopefully. So we'll first do a demo on how to implement tasks and live build a task system, interface, and backend. Then talk a little bit about delegation, just share some directional guidance for evals. There's a lot we could dig into here, but hopefully we'll give you a few tips to get started. And then finally, we will end with Q&A as always. This is a new platform that we're using today, so just wanted to share, if you click Q&A, there should be a text field that pops up. Ask questions. We have a couple folks in the room here who are going to be answering, and then Alon will answer live at the end.
Yeah, absolutely.
All right, you ready to do some coding?
Let's do it.
All right, over to you.
Cool. Hey, everyone. Yeah, so we have a lot of stuff that's new. And to start off, we can just go over a few of the agents that we launched this year, right? So we launched earlier this year, we launched Deep Research, O3, Codex. 2025 is the year of agents, and we're really seeing it happen. And to start off, let's just do a little quick demo of Codex. I know some of you might be interested in using this soon. So just to kick things off. So here I actually have the repo for the Codex CLI, which is not the demo I'll be showing. I will instead be showing how to use Codex on ChatGPT. However, the reason I have this open is just to grab like a sample task and show you how you could use Codex. So here we have this issue that someone pointed out that Codex does not respect the API keys through environment variables for other vendors, right? So, this isn't great. So what I'm going to do is just like highlight the whole issue and just drop it into Codex, right? So I'll say like, can you fix this? And then, I'll give it a bit of context. I'll give it the title. And as you can see, I have Codex enabled. And so what it'll do is it has a local copy of this repo that it can like run tests and actually write code in. And so I'm just going to kick this off. And off it goes. And in the background, it's just going to go through, check all of the different parts of this issue, and then do the changes it can. And so if we take a look at what's happening in this log, it's downloading the repo. And we're not going to watch the whole thing happen, right? But this is kind of the interface that you'll expect with Codex, where you have this like long-term task where you just want to give it the end state, you just say, this is what I want you to do, figure out a way, and off it goes. And it's using the environment. And we'll get back to it at the very end, right? But this is just a sneak peek of Codex. You can already use it right now. Now, the reason this is relevant to our build hours today is because you will be implementing your own agents soon, right? And part of the reason of bringing these agents up is to give you a background for like what yours can look like, because the technology that we used internally for O1, O3, Codex, everything is actually mostly out in the open for you to build as well. So this is how you can build your agents. The Responses API is an incredibly powerful API, especially as of yesterday, where we launched hosted tools, MCP, so much stuff. Unfortunately, we don't have a lot of time to get into everything that we launched, but essentially with a single API call, you can now set off this like entire sequence of events where the agent can query files, call MCP servers, etc. The Agents SDK is a really handy way to implement this same loop, but where you can do local function calling, and it has a couple other features like handoffs, and of course, hosted tools and MCP. These are some of the tools that you can use to build. So today we're going to talk about agentic tool calling, right? And how all the things that we talked about really come into this one idea. So what is agentic tool calling? Really, it comes down to reasoning and tools, right? So you can think of something like deep research, Codex, or O3 as just going through reasoning with tools. But why is this interesting, right? And the big part of this is really reasoning, right? So last year we trained O1, where we really taught models to reason for the first time. And what this meant is instead of showing them like, here's how you do a task step by step and hoping that it learns from our examples, we instead let it figure out how to get to solutions as it reasoned. And we would just grade on whether it was correct or incorrect, right? So through reinforcement learning, O1 learns to hone its own chain of thought to refine strategies it uses. And so this is the first component of agentic tool calling is reasoning, right? We train the models on solutions, not the steps that make them up. They figure out the steps, and reasoning emerges, right? And then you can take function calling or tool calling, where you take actions and fetch information. And when you combine them, that's when you get agentic tool calling. And so what you can see in this diagram is pretty much what happens is now within this reasoning and this chain of thought that the model is doing, where it figures out how to think about things, we now also give it access to tools. So it can figure out not just how to think about things, but how to do things as well. And so the paradigm is very similar. We didn't train it on like this chain of thought, like on specific steps that we wanted to take. We just train it on results. And it learns to take the actions to actually achieve those results, which is the really powerful part of RL that we're now bringing into models, not just for thinking, but for doing as well. And what you see is this long-term agency that is really, really powerful. And so this is what we're calling agentic tool calling. And what results is a model that is goal-oriented. It's resourceful, right? It'll figure out a way to get you what you asked for. It's very robust to recovery. So if it gets failures during the tools, it can actually course correct and get to the end. And it's really consistent over long horizon tasks, right? You can actually have like tens, hundreds of function calls in a row. The Codex, I think, does in the order of this, and it stays consistent. And so this is the power of agentic tool calling. So with this agentic tool calling capability, we can actually start thinking about a new primitive or a new abstraction, which is tasks, right? Everything used to be very chat-based, and now we're entering this world of long horizon tasks. So what goes into a long horizon task? Or like, what do you consider it? And this is where we start to go a little bit from theory more into the actual practical land of like, what does it take to put together a task? So of course, you have the agent. I guess to talk about these, you have the agent, which describes what does the task do. You have infrastructure, which is how do you actually run it? How does it do it? You have your product, which is how does a user use it or interact with it? And then evaluation, did it do what you wanted it to do? How well did it do it? So for agents, you're going to be thinking about goal specification, which is kind of different from before. Instead of specifying step by step what you want to happen, you have to specify what the end state that you want is. So you also want to specify the tools, which will give it access to the different resources that you have. And this way, your agent will be able to interact with your own systems. This is also where you might want to use delegation, where you're no longer talking to just one agent and waiting for it to be done. It might be able to kick off other tasks as well. And how you choose to interact with like async long-running function calls and human in the loop. Now, infrastructure is where you start to think about these like parallel tasks and parallel execution, and how you manage the state between like one agent and your product and your backend, as well as the runtime environment. So Codex has a runtime environment for each of the different like repos that it has, and you might want to set up one for you. And then this is also where you choose how to handle failures, retries. This is like the nitty gritty of like, okay, we have agents, like we have these concepts. How do you actually run them? And what does it look like, with code and with your like backend architecture? Then you have your product, where you can choose how the user interacts and what they get to see. And so this is where you can surface progress. Like, how do you keep them informed of what the agents are doing? This is also where you work with the user essentially to provide the agent all the context it needs to actually accomplish the tasks. And this might be explicitly by asking the user, or it might be explicitly how we might do it in a second, where it is just gathered from the context itself, or like from the application context itself. And this is also where you can choose like how do you visualize tasks, right? Like Codex has this like list of tasks below, and then when you open it, you can see the like all the things that it's doing with these nice animations. And so this is where you can actually have fun with it, right? How do you keep the user entertained and give them insight into what is going on? Because I forget off the top of my head where this is from, but like I think it's pretty intuitive. Like a user who just like doesn't know what is happening behind the scenes and is just waiting will A, get more like stressed and impatient, and B, will actually trust your output less if they don't see what is actually going on. So finally, you have evaluation. This is where evals come in, where you want to collect examples, define how you want to grade. And so this is a little bit different from before, where you really wanted to evaluate like turn by turn. In a chat conversation, this is like the most common way that we used to do it. Now with tasks, you actually are more interested in the end result, and maybe less interested in what each of the turns the model took was. So you might want to set up like these graders that are now often like LLM-based graders, where you give it a rubric and you describe what criteria you're looking for. I like to sit with people when we've worked with companies and just ask them like, okay, is this good? And then have them say yes or no, and then it's like, why? And then just ask them and go through and really break down the task and what makes something good. And maybe a little sneak peek here is if you have a few examples, you can actually fine-tune a model to be your grader. And this is actually a great case for reinforcement fine-tuning that we launched, where if you have a good golden set of examples, you can train on that. And then finally, tracing. To do all of this, you want to, evaluation is not just about running evals, it's also about like monitoring, evaluating it online during its interactions with the user. So these are the parts that really go into tasks and when you consider how to build them. So I think this is enough to, yeah, I put things in different groups here, but everything is really connected, right? Like, async and human loop might actually have to do with like continuing long-running tasks on the infrastructure, and like the product might be include delegation. So, this is like, let's say the four corners, but there's no clear lines between them. So I think with that said, it's time to start coding. So we're going to take a stab at implementing tasks. And today's prompt is, let's say we have a lot of tickets, like a backlog of tickets, right? Customer feedback, etc. Let's build an agentic task system that can actually take them on and resolve them. This is kind of broad, but it's kind of to show how broadly these agents can work in practice. And so this is kind of, let's ignore the issue. This is roughly what we're aiming for, right? Let's say we have this customer service portal or like this feedback portal with a few different tasks. What we want to implement is this system that can actually take these tasks and operate on them. And this is going to require like defining your agent, defining some infrastructure to run it, and also defining like how you do the interactions, or what interactions the user has and how they see this. So let's get started with the agent in a pretty simple way, right? So this is actually a very powerful API call already. When you specify a response, you can actually give it hosted tools and have that run in the background. I added this because yesterday we launched background mode, which actually takes a lot of this and like makes it a little bit easier if you're not using local function calls and all you're doing is MCP and hosted tools. I'm gonna skip this for now because there's a lot to get through. So for the first thing is we're gonna use the the agents SDK. And what this SDK does is it wraps this like loop that we actually implemented it in my first build hours, which was implementing an agent. It's very similar, and it's based on the Swarm, if you're familiar with that. So here we have the simplest agent, and let's just run it real quick to see what the interaction is. So hi. Can you say hi to everyone watching today? And as you can see, we can stream the results and we can see the reasoning. Great. O3 is pretty friendly. So it's funny because getting to this point last time actually took a lot of work. But now because we have the agents SDK, it really is just throwing together a quick agent. Now, let's start adding some tools, right? So if we go back to this, we might want to take a look at one of the tasks, and it says, customer reports being charged twice for their monthly subscription. So let's start building some tools for the agent to use here. Now, we're going to have to think about tools and also the prompt and how we specify the goal. So I have some code ready, but I like doing this live with you all. So let's just start typing up some functions. So cursor is very helpful here. It sort of knows already what I want to do. Here, we're not going to search the web. Instead, let's say we want to give it access to, I guess get user data, right? And we can take a user name, and then we can just return some mock data. And then let's, ask it to be like, include recent order history. Cool. So now, when it queries for a user, and similar to the Swarm, just by specifying a function with Python, it'll actually take this and turn it into the right schema and give it to the model and execute it. So super nice way to do this. Cool. So we have this first function. Let's try this out really fast and just say, maybe let's give it some instructions. Say, great, thanks, cursor. We can say, Milan, I'm upset because actually this isn't quite a goal. Let's pick a goal, right? So we have the user data, and then maybe let's add another function for like refund. Cool. Yeah, let's mock it out. And let's make one for order, get order details. Okay, cursor is actually amazing. So what we set up here is we want to have this ability to like get recent orders. Now, we can then take those orders and return some details on them, including the price. And so for this flow, if I want the model to be able to perform a refund, I want to be able to specify like the functions, my problem, and have it figured all out. So this is all live, so anything can happen, but let's see. I can say like, I really didn't like the last thing I got. I want a refund. So the model is reasoning. Can you just check my recent orders? So now it uses the first function to get the orders. It shows them to me. So what we're seeing here is it's still pretty interactive. This is kind of the normal approach. But let's add an instruction, and this is why specifying the end state is more important than specifying the steps. Let's say, get all the context you need up front, then execute task to completion without asking for more. And let's add one more, just say like, if you have everything you need, just go. This is not entirely what you might want to do, but this is just to show how I can say like, I'm Ilan and I want a refund on my last order. So let's see. Okay, it's getting the user data. It's getting the order details. It's submitting the refund. And that's the end. And so this is kind of to show by specifying the end state, you can actually have the model figure out the steps required to get there based just on the tools. Cool. So this was a simple start. Now let's move on to product and actually integrating it. So if we have this front end, we are actually want to connect to a backend, right? And in order to keep using the Agents SDK, which right now is in Python, JavaScript 1 coming in soon, we'll want to set up like a very simple like Flask setup, right? So I'll do this one by hand just to show you guys how to do it. Let's do quick server. I guess I have one right here, right? So I'll start off with, from Flask. Okay, very, very basic Flask server. Now, let's say we have like a, task endpoint. Here's where we're going to want to run our agent to actually perform the task. So this pattern, and then stream back the results. So this pattern is, I don't really know what a good name for it, maybe like a foreground task, but essentially it means that when a front end connects to it, it stays that like the connection is what keeps the task alive. And if we go back to our slides, this is what this would be, where each new connection actually starts its own task, and like the connections are managed from the front end. And so this is useful if you want first of all, it's very simple to implement, and second of all, if you implement it this way, then when you connect, you're essentially going to be getting the stream of the events for that task. So actually, let's start with the simple server here. I'll walk through it. I think it's better than watching me type everything. This is slightly more code than I usually do for these live build hours. So let's take it easy. Let's take it slow. First, we define our endpoint, which is going to be an SSE endpoint. We grab from the body the input items and the previous response ID. And we use the assistance API runner.run streamed, right? And what that does is it gives us a stream of all the events that the agent is doing. We're passing in this agent that we can actually import from the one that we defined. So if we defined it, where was I? I think I was in one agent. So I'll import it from there. It's 50-50. Oh, it's not happy with that import name. That's fine. I have another one implemented. We'll be using that one. I'll show you in a second. But essentially, we have this runner, we can run it. And then for each of the events, we actually get different kinds of events from the agents SDK. We want to get the raw response events, which represent the actual events coming from the responses API, because the agents SDK is by default backed by the responses API. And what we do is in this event stream that we're defining, we run it, and then we just yield them back, and we encode them with SSE. This is mostly just piping, but I think it's important to show like what kind of thing might go into this. And then at the end, we'll yield like a done, and then we return a stream. Now, already with this, we have implemented something that looks like this, where from a front end, we can make a connection to a backend, run the event, and then wait for everything to come back. So this is a good place to start if you are just prototyping or making something. But in reality, you might want to be able to handle a task where it is created in the background and then disconnected. And you might see this in ChatGPT, where you can type something and close it, like completely close it, and then come back later and it'll be finished, right? So this is implemented with a different approach, with a background task queue. So let's take a second to just walk through this architecture, because this is what we're going to be using in practice for the front end that we just created. So we have our front end, which needs to be kept in check with the backend that has the tasks. What we can do is open an events connection to the backend that just receives all of the new task events from the backend. What are these events? This is like adding new items to the tasks, updating to-dos, pretty much anything that modifies the state of these tasks. Now, how do we actually kick this off? We can use a task endpoint. So here I've labeled in yellow what is like an SSE endpoint that is meant to stay open. And I've labeled in gray anything that is just a post request. And this has the shape of a background task, right? Where you just make a post request, which starts the stream, and that's it. And you disconnect. And you could actually start this task from anywhere. So this architecture actually can scale nicely. What you can implement this way is, once you have your backend, you can send tasks to a task queue, which is actually responsible for running your agents. And then you can take the events, and any events that come out of that, just associate them with which task it's related to, and you stream them back. So this is the main architecture. Let me walk you through what the implementation can actually look like. Okie dokie. We have a lot going on, so I'll go slowly. This is the task object that we are defining. We just wanted to have an ID. This items list represents the items that actually make up the conversation history, or like the action history of an agent. We will get into to-dos for a second. Let me delete this for now. And we have this status. Now, the global variables that we have here that you might actually want to persist somewhere, but we are not for this demo, are the actual tasks mapped from their ID. This async IO event queue, which just lets us run things, what we're considering in the background, and then our fast API. Now, let's go all the way to the bottom, and I'll show you the two routes that we have. So here's the two routes that I showed you in the diagram earlier. The first one is the events route. And so what this does is, you can see it's a pretty simple one. It's maybe a little bit hard to follow, but essentially what it does is forever, right? As soon as you start a connection, it'll just forever stream these events. Wait for this events queue to receive something, and then forward it to the front end. And that's all it's doing, right? It's just taking from this event queue and sending it to the front end. And you'll see why this is important, because when we have this events queue, if we have this endpoint that a front can connect to, it'll just guarantee that anything we push to this events queue gets routed to the front end. And what we can do is push updates from any of the agents up to this event queue. So that's the events endpoint. Now let's take a look at the tasks endpoint. Just like before, we take the body, we parse it, we grab out the items, we grab out the previous response ID, which, if you're not familiar, is a very convenient way to specify what the previous requests were, so that you don't have to pass the context each time. And this becomes really important when you want to do this chain of thought tool calling, because you want to make sure that when the model is calling a function, it actually has in its history the rest of the chain of thought. So it really is function calls within a chain of thought. Now we can create this task object, save it to our tasks. And then here is where the important part is. We can publish, and I'll show you this function in a second, that we have created a task, and then what the task ID is. And so if we scroll up to publish, all we're doing is taking the events queue that we were talking about before and giving it the event itself, encoding it as SSE so that the front end can take it and decode it. Cool. So finally, once we create the task, then the last things left to do is to actually kick off our worker, kick off our agent, our task. And so this task is actually a bit overloaded. This is just a function that is part of the async IO library. It considers a task like a background task, which actually fits very nicely with our analogy. So we can take the async IO worker and then give it a worker function that we'll get into in a second, and kick it off in the background. Now, and then return the task ID for the front end to be able to have it. But so this is kind of where the juicy bit happens, right? What is happening in the worker? Well, it's very similar to what we had before. All we're doing is we're going to take our runner, give it the agent, which includes the prompt and the tools that are defined, give it the input items, which is the input from the user, the previous response ID so it can stay consistent with the previous conversation, give it the task in a context variable. And so this is important later for it to be able to modify its own task. And this is a nice pattern in the agents SDK where you can supply objects or context to an agent runner so that when an agent is running, they're not in the LLM's context, but they are accessible by function calls. So the model doesn't see it by default, but it can use it like a memory bank, where it doesn't see it in memory, but it can make changes to it. It's just a convenient way. It's a way to represent like a closure or just any kind of state that is tracked along with this run. And then what we have before, which is for all the events, we filter out, and for all of them that are response events, we publish them down to the front end so it can actually render them. And we also set max turns to 100. You can set this to any value you want. Great. And so this will run until the agent is finished, and then we'll just set task to done and push down an update. And you'll see this pattern a lot where I make an update to the task object, and then I push that same update down to the front end, and that's just to keep them synchronized. So the tasks that we represent in the back end are the same as the ones we represent in the front end. So this was a lot, right? But this is actually everything that we have. We have the tasks endpoint, which actually kicks off a task and returns the task ID. We have the events endpoint, which connects the front end to the back end and streams all of the events from all of the tasks. And we have the actual worker, which takes the runner, runs it in a streaming mode, and then all of the events just publishes so the front end can have. Now, these are the components. I'm going to go back to the diagram so we can see what this looks like. This is what we have made, right? We have made a system where you can start tasks, give into the task queue. They'll run the agent, and then we'll forward the events back down. So let's take a look. I'm just going to refresh everything just so we have the best shot. Here on the left, I'm running the front end. So I'm going to run it again. And here we have the back end. Let me just make sure I'm not lying to you and I run the actual one. Server. And right now I'm importing an agent, but since we already defined one that was, so nice, let's just use this one. So I can really just grab this and pull it in. this isn't the great best practice, but it's because I'll change the name to, my agent. And now from here, I can my agent. Amazing. So, this is all live. It might work, it might not. But essentially what we did here is the agent that we defined earlier, we're going to run and see it in the front end. So server queue. Did I also bring in the, let's kill this. Let's rerun that. Go back to our front end, rerun this. Okay, now if everything happened correctly, and I wired up the front end separately. I'm not going to be going through the front end because that code is kind of a little bit all over the place and I don't want to be switching languages. But essentially, when I hit start investigate, right now, when I connected to the website, we can actually see in the servers that it sent a get events call from the website to the backend. So it starts receiving the events. And right now, we haven't streamed anything. But now when I hit start investigation, it'll supply the context, start a task, and you can see that the events are actually streaming from the backend. So we're going to get user data because we supplied everything together. And then it's probably going to tell me it can't do something because we didn't give it the right tools. Yeah, it gave me some response because, again, we didn't design this agent for this website. So let's actually design an agent for this website. And for this, I'm going to go into this agent that I've defined earlier. So if we just go through the prompt, you're a helpful assistant. We're going to ignore the to-dos for now. Running in non-interactive mode, final output, great. What we're saying here is just keep going until you're finished. And we're going to delete anything about to-dos. I'll get to that in a second. But now, if we refresh everything, so sorry for all the motion sickness going back and forth, then we should actually be using this new agent. And so what can this agent do? It can get weather, search open tickets, read document, get runbook by category, search policies, get emails, add ticket, write document. We specified these functions up here, and I made this mock API that essentially just returns like mock data for all of these. But this is just an extension of what we were doing before. And in reality, obviously, instead of hitting a mock API, you'll hit a real API. Everything would work just the same. So let's give this a shot. If we start here, it starts a task. Ignore the progress for now. That is the next thing we're going to be doing. But we should be able to see it reasoning. And since we're streaming all of the events, we can actually run multiple tasks in parallel. And so here we can see the reasoning happening, get user data, it's loading it. And for this one, it's going to go through a different process. So is it going to give up immediately? It probably will. Oh, did I not switch it out? Oops, my bad. Let's go here, and let's go back from using this to server agents. Once again, I'm just going to do this one. Great. Okay, so now it's actually going through the functions that we defined, going step by step. And we can see some progress, right? But it would be nice to be able to have more of an insight. So here's where we get back into the product sense, right? How do we surface progress to the user? The chain of thought events are a nice way to do it, and there's other ways to render it. But there's this cool pattern where you can make to-dos or make have the model essentially have a function to surface progress to the user. So how would we implement this? Well, what we can do is we can take the task object and add this to-dos field. And once we add this to-dos field, for now, it just does nothing. But the magic happens when we give the model functions to update this to-do field. So this is a new function, just like the ones we were implementing before, but it's a little meta. It actually uses the task in context we passed before, and and the model can supply the actual task that we want it to run. And so for each of the text in the to-dos, we create a new to-do, look at the add it to the actual task, and then publish it back down. And then we also give it a function to just check off to-dos. So what have we done? We've declared these two additional functions, and then we're going to add them to our agent to add to-dos and set to-dos. And this is a very tiny thing, but it actually feels very magical when it works. And so let's take a look at that. And maybe we want to add the thing I removed here. Cool. Now everything about to-dos is there, so always create a plan with to-dos, and always start by setting the to-dos. And then check them off as you go. Cool. Fingers crossed. So let's try the same task again. And so now, if we're lucky, and the model does what we want it to do, the suspense is killing me. Ta-da! Now we have some to-dos, and we can see them in the front end. They can actually drive our progress and the idle. And as the model goes on, we get this like kind of magical insight into how far along it is. Without having to build any like monitoring system or any other pieces, we can just have the model go through and check them off. Yeah, and just like before, we can like kick off multiple in parallel. And I actually am not the biggest fan of chat interfaces. I love just clicking. And so this way of just like grabbing all the context, shoving it in, so that the model has everything it needs, is like, in my opinion, a very delightful user experience. Anyway, so now we can see that it's gone through. Now, you may be wondering, why don't I see the function calls to check the to-dos? And the answer is I am explicitly filtering them out in the front end. And this is how you keep some of the magic, right? If you just don't show the user how it's doing it, then it's just going to keep going and it'll look more natural without like checking off the to-dos. But yeah, I want you to just maybe take a beat, take this in. Like, what does this mean for your product? If you have anywhere that would benefit from these like long horizon tasks, or anywhere where you want goals fulfilled, or anything that requires multiple more open-ended steps, this is something that is actually quite useful. And these patterns of running tasks in the background, showing progress, just really come in handy. And so if we go back, there's a whole other bit about delegation. I'm not going to go into it too much. Maybe we can talk through it really fast. So delegation is the notion of like, right now, I am kicking off the tasks by hand. We went before, like we have this task. What if we want the model to kick them off, right? Like what if we want to, instead of clicking ourselves, which I actually love, don't get me wrong, but if we want to like have ChatGPT or like your agent actually kick off tasks, but we can keep talking to it, we can implement this pattern where you front load the context gathering. It asks you follow-up questions. If you used deep research, this is what it feels like. Before it starts off on a long task, it makes sure it has enough information. It starts off that task with a function call, which actually returns immediately. And you can keep talking to it. Meanwhile, the task is running in the background with an architecture similar to the one that we ran. And you can keep chatting with it. It's non-blocking. This is optional, but this is an approach I quite like. And then once it's done, it can come back and actually update you on it. I included an example of delegation, and I think we have enough time to go through it really fast. So why don't we do that? So this one is once again text-based. I didn't build out the UI for this, but I said I wasn't going to talk about it. Maybe I will. Where we need a system to run this in the background, right? Like if I just do a function call that like calls O3, for example, and like maybe in the front end I'm talking to like GPT 4.1 mini. If I don't have this enabled, and for example I go here and I say, and just to remind you what I have on screen, I have this agent with no tools set right now. That is just 4.1 mini. Maybe let's set these 2 tools, right? This is all I have. What are these tasks doing? This function just calls the responses API with our input, and then get tasks can retrieve this. So right now, this is not super interesting because I can say like, I'm gonna ask it to do something hard, like write a poem where every word starts with the next, I don't know, prime number, if it was indexing into the alphabet, something like that. If I ask this to 4 mini, it's probably not gonna be able to do it, but I'll say, start a task with this. And by starting a task with this, if we go back it's actually going to call O3. So let's see if this works. Oh, it really just tried. Okay, I'm going to say, instructions. If the user asks you something too hard, start a task with it. Cool. So let's try that again. I don't want to type this out, so I'm going to copy it. Oh, it actually, maybe it did a good job. Wow, 4.1 mini is a good model. But for this example, we really just wanted to call the function. So it starts the task. And now what is this task doing? We are waiting for a response from O3. And O3 is going to do this very, very carefully. Oh, it actually did some of the work for it. Wow, 4.1 is a really good model. But we're blocking. We're just sitting here. We can't keep talking to it until O3 is done. However, if I enable background task, then what I can do is a very similar thing, but now it should return immediately. And so I'll say this. It should start the task, and then we can why is it not happy with me? 500. Okay, we launched yesterday. We're going to ignore this for now. But I think what I want to show you here is if you have a background system that you're either depending on OpenAI for, or you implement it yourself, like we just did for the Agents SDK, then you can use function calls to essentially hand off not hand off, like delegate a task that will happen in the background, and then just check up on it or push updates to your main agent. And so what the experience to the user can be is non-blocking. You can just keep talking with it and service them. Sadly, I couldn't show you right now. Maybe, let's see, maybe I do have the simple server. Should we try this? Let's go. Oh, no, this blocks. This blocks. We could do it with the other one, but I don't really want to fumble around too much live. Done that a bit too much. Yeah, we would have to implement the task. It's fine. We'll skip it. But hopefully you can believe me, right? We have this back-end system. And so what you can do is have a function to start, which returns immediately, and you'll be off and running. So I want to end this here so we can get straight to questions. There's a couple of things we wanted to talk about. We didn't get to. We'll be sharing more resources after. But yeah, shall we jump into questions?
Let's do it. If you bring back over the deck, I actually dropped them in for you. Can you update it, refresh?
Yeah. So what are the most efficient ways to orchestrate sequential and conditional tool calling? So I get this question sometimes, and it always, it's an interesting question because the whole point of agentic calling is you don't have an expectation for like sequential or conditional, like you want the model to do whatever. Like you just want it to figure out how to get to a solution. So that being said, if you do want to have something kind of conditional or sequential, just use Python, right? Like code is an amazing way to express sequential and conditional things. If you want O3 to like always call 3 functions in a row, instead of like hoping it calls those 3 functions, which is also higher latency and more expensive for you, just put them all in one and then have that function do the 3 things that you wanted. So that's kind of my answer there, is like Python is very powerful. Use code when you want like this sort of task. You can also like enumerate it in the prompt. O3 is really good at like following those instructions. How should memory be managed in agents handling long horizon tasks? Another good question. There's many different ways, right? Its own context is like a pretty decent memory bank. You can also have explicit memory systems. So in a very similar way that we were like creating to-dos and checking off to-dos in an external state that the model can't actually see, it's not in context, you might want to implement like a way to give it like a way for the model to remember things, to save facts and then recall them later if it's necessary, either with a vector store or something similar. We actually did something very similar in the original version of ChatGPT's memory, where it would be able to like explicitly choose to save a fact based on what you said, and then at a later time, like bring up similar facts to a prompt. And the way you can do that is just doing these like vector comparisons, embedding comparisons. I won't get too much into it, but there's many ways. An external memory store is useful. How many tools is too many tools? You can take it up a lot. I try to stay under 20-ish. That's like very heuristic. But at that point, it's not so much about can it even handle it. It's like, what are you really describing? And so the Agents SDK, and I didn't get into this here, has this notion of handoffs. And if you check out the Agents and Assistants build hours, we do get into it more. But essentially, it lets you specify multiple different agents that can pass off or hand off a conversation between each other, where the one that has the most appropriate tools will get it. And we'll get it in a way that doesn't have to be rerouted with each time. So 20-ish, maybe. Can you use OpenAI hosted functions together with your own custom functions? Yeah, of course. This is actually a really great pattern where I didn't implement this here, but if you want to, for example, use like code interpreter to analyze some results from database queries, you can absolutely do that. You can have functions that retrieve certain information or like load in certain like numbers, for example, or some table, and then the model will choose to do that and then use code interpreter to run and then give you results. So yes, it's actually highly recommended to use these together. Does the Responses API natively support MCP? As of yesterday, yes. So as of yesterday, any remote MCP server you can actually add to the Responses API, and it'll make those remote calls. And so this is where the magic of the background mode comes in. It's like usually the only reason the Responses API has to come back to you before like the agent is done is when it wants you to run your own local functions. But if you have no local functions, if you've implemented everything with a remote MCP server, then you can actually just run it and set background to true and just kind of like forget it and check in later. And that can be like essentially one very long Responses API call that can do all these different things, like MCP, file search, image generation, etc. Okie dokie. Just realized this guy. This is cute. Cool.
I had to add that in. This is really sweet, and everybody in the room that's answering questions, this made them smile. So I'm glad that this has been helpful, and really appreciate you taking the time to teach us how to agent. I loved that.
This is cute. I like it. Are there any more? Or was that the last one? No?
That was the last one, and
Okay.
we are running perfectly on time. So if you go to the next slide there on resources. So Thank you, Alon, for blessing us with this wonderful hour of building and doing lots of things live that we haven't built with before.
No, we're blessed by everyone building all of this. This is all possible because of everyone at OpenAI. So this is
true.
yeah.
This is true. What a happy note to end on. We're going to follow up with some resources. So we're going to share the GitHub, which has all of the repos from prior build hours. You can see upcoming build hours on the landing page, as well as recorded build hours. If you want to spend more time with Alon, you can watch his previous build hours where he talks about assistants and agents. And then we'll also send out a link for a practical guide for building agents. There were a few questions that were coming in for the chat that I actually think this would be a really good starting point for. Our next build hour is going to be next week, and it's all going to be about image gen and the API. We have lots of really exciting demos to go through, a customer story that we will share, and we're looking forward to seeing you in more build hours. So thanks for tuning in, and happy building.